Hello, I am Trevor Moore, and today in this video I'll be going over homework assignment number 2. The topics covered will be from chapter 1 and chapter 3 of our textbook. In chapter 1 I'll be going over proprioception, how muscle spindles work, and how the activation of muscle spindles results in a stretch reflex. I'll be going over the specific example our book covers, which is the knee-jerk reflex. In chapter 3, we'll be covering how carbohydrates are processed in the human body, the 2 pathways of carbohydrate processing, and how these pathways relate to athletic performance. Specifically, we'll be discussing the triangular method for energy processing and where the marker for the energy source would be for a 100-meter sprint, for a soccer goalkeeper, and for a soccer midfielder. All right. First, I will be covering chapter 1. The first topic will be proprioception and how that works. So proprioceptors are specialized sensory receptors located within the joints, muscles, and tendons of the human body. These receptors are sensitive to pressure and tension, so they relay info concerning muscle dynamics to the conscious and subconscious parts of the central nervous system. This provides the brain with info concerning kinesthetic sense, which is the conscious appreciation of the position of body parts with respect to gravity. So where your body actually is in the current moment and where it will be in the moments following. Most of this proprioceptive info is processed at subconscious levels. So we do not have to dedicate conscious activity towards tasks such as body posture, or position of body parts. So it's your brain's ability to be able to maintain either a upright body position, the seated position, wherever your arms are in relation to that, without your brain having to do any work as far as thinking about keeping that posture, keeping your legs still, keeping the arms by your side, or wherever that body position may be in the moment. So to summarize the first topic of proprioception, it is your body's ability to sense its own position, movement, and the forces acting on it in space without relying on any visual input. People often refer to it as the sixth sense because it works continuously in the background, allowing you to walk, touch your nose with your eyes closed, or adjust your grip without thinking. So it's any sort of movement that your body can make without actually having to make conscious thought to actually do it. The second topic that I will be covering in chapter 1 is going to be muscle spindles and how they work. Bouncing off of our first topic of proprioception and proprioceptors, muscle spindles are proprioceptors that consist of several modified muscle fibers enclosed in a sheath of connective tissues. These modified fibers are called intrafusal fibers. They run parallel to the normal or extrafusal fibers. Muscle spindles provide information concerning muscle length and the rate of change in length depending on what sort of activity the person is doing. When the muscle lengthens, spindles are stretched. This deformation activates sensory neuron of the spindle, which sends an impulse to the spinal cord. Once this signal is sent down the spinal cord, this is where it synapses or connects with motor neurons, resulting in the activation of the motor neurons that innervates the same muscle that is getting sent the signal. Spindles indicate the degree to which the muscle must be activated to overcome the given resistance, whether that be a light or heavy load. As the load increases, the muscle is stretched to a greater extent, and the engagement of muscle spindles results in the greater activation of the muscle. Muscles that perform precise movements, such as the eyes and fingers, have many spindles per unit of mass to help ensure the exact control of the activity that they are doing. That is why you can make very precise movements with the eyes, depending on where you're looking, direction and time. You can do those very quick and very precise, as long as you have healthy eyes. And then same thing with the fingers. That's why you are able to make precise movements, such as grabbing things with just a couple of your fingers, holding a pencil, quick reaction time with them, as far as grabbing something while it's being dropped, all those sorts of things. The last topic that I'll be covering in chapter 1 is how the activation of muscle spindles results in a stretch reflex. Specifically, our book in chapter 1 talks about the knee jerk reflex, and that is what I'll be covering today in this video. So tapping on the tendon of the knee extensor muscle group below the patella stretches the muscle spindle fibers. This causes activation of extrafusal muscle fibers in the same muscle that is being targeted. The knee jerk occurs as these fibers actively shortens, which shortens the intrafusal fibers and causes their discharge to cease. So when a muscle is stretched, deformation of the muscle spindle activate the sensory neuron, which sends an impulse to the spinal cord, not the brain. This action happens so quickly, and it is from the muscle spindles. So that is why it is sent through the spinal cord, where once that occurs, it synapses with a motor neuron, which causes the muscle to contract. And again, in this example, that is the contraction in the knee jerk reflex. For the rest of the video, I will now be covering chapter 3. The things I'll be discussing is how carbohydrates are processed within the human body, the 2 pathways of carbohydrate processing, explaining how these pathways relate to athletic performance, and then I will be lastly talking about the triangulation method for energy processing and where 100-meter sprint, soccer goalkeeper, and soccer midfielder would be using their energy source from, while relating it back to the triangulation method. Looking at figure 3.2, it is illustrating how carbohydrates are converted into usable energy. Glucose or glycogen enters into glycolysis. ATP is then invested and produced, which leads to the formation of pyruvate. And then, depending on oxygen availability, pyruvate either enters the mitochondria for efficient ATP production or is converted into lactate to sustain energy during high-intensity exercise. The first pathway I'll be discussing is anaerobic glycolysis. It is faster but shorter than the second pathway that I'll be discussing. But anaerobic glycolysis is when pyruvate is converted into lactate in the sarcoplasm. The second pathway is aerobic glycolysis. This one is slower, but the duration lasts longer. And then this is when pyruvate is shuttled into the mitochondria and undergoes the Krebs cycle. The textbook refers to these 2 terms, aerobic and anaerobic glycolysis, as not the best terms to describe them because they are not solely reliant on oxygen to determine the pathways. Some sporting events that would use anaerobic glycolysis would be a 200-meter sprint, 100 to 200-meter swim, or 500 meters of speed skating, Now, going to aerobic glycolysis, some sporting events that would use this pathway would be a marathon, distance cycling, or an 800-meter swim. Now moving on to discussing the triangulation method for energy processing. The first example will be for a 100-meter sprinter. For the 100-meter sprinter, the ATP PC system will be used the most, the phosphagen system. And this will be providing the majority of the energy during the duration of the race. As the race approaches the 10-second mark, which would be most individuals unless they're elite level runners, anaerobic glycolysis begins contributing during that last 20 to 30 meters as you get to 10 seconds or a little bit above it. So looking at how it would appear as far as the triangulation method goes, it would be very close to the top towards the phosphagen system with a slight lean going down to glycolysis, which would be anaerobic glycolysis in this case. So ATP, PC would be 75-85% of the energy there, where anaerobic glycolysis would be 15 to 25% towards the end. Again, elite level 100-meter sprinters might only be using ATP, PC with a slight lean towards anaerobic glycolysis, but lower level runners will definitely start experiencing some anaerobic glycolysis in their run. Now I'll be discussing a soccer goalkeeper and where they fall in the triangulation method as far as energy processing goes. For a soccer goalkeeper, they're doing a lot of short, explosive movements. They do have long periods of low activity, though, between these explosive actions waiting for the ball to be on their side so they're actually doing something. So in that recovery period, they're relying on the aerobic system between those fast spurts of energy. So when looking at the triangulation method, still going to be close to the phosphagen system, but far away from glycolysis or anaerobic glycolysis, because between those bouts of explosive movements, they'll be relying on the oxidative system for the recovery. And then those short, fast, explosive movements will definitely be from ATP, PC, which falls under the phosphagen system. The last person I will be talking about will be a soccer midfielder. A soccer midfielder typically covers the most distance in every match, typically between 10 to 13 kilometers, which heavily relies on the oxidative system for this sustained play. However, they are also performing frequent sprints, accelerations, and changes in directions. So ATP and anaerobic glycolysis systems do contribute. Overall, though, they are heavily reliant on the oxidative system. So when looking at the triangulation method for this one, still going to be closest to oxidative, but they are using the phosphagen system as well as the anaerobic glycolysis and those faster bursts of movement. But that sustained play, that'll be leaning way more towards the oxidative system. So that's why the dot is still leaning towards it. For this sustained play, aerobic, about 65 to 75%, ATP PC, 15 to 20%, and then anaerobic, 10 to 15%. This concludes my video assignment on homework number 2, covering some questions from chapter 1 and chapter 3. Thank you.